So to kind of pick up where we left off yesterday, we were talked about arrays, how arrays and collections are similar, how arrays and collections are different. Collection classes provide methods to perform operations arrays don't provide. We'll take a look at some of those. Arrays are always fixed in size, collections are variable size. We'll take a look at that. When you declare a list, it's a little bit different than an array. Down here. So an array, we do a data type, give it a name, square brackets, give it a name. And then redeclare the data type and then size of our array. With a list, this time we just do a list. We call it a list. We say what data type we want inside the angle brackets. So you do your list, the keyword list, angle brackets, what kind of data type it is, and then you can name your list whatever you want to. And then you do a new list. So it's a little bit different setup than an array. They have a sorted list. That K and the V there is a key and a value. I'll give you an example of that here as we go through these slides. A queue and a stack. You don't see a queue used too much. Occasionally you'll see a stack used, but not as often as you do just an actual list. The using directive for an untyped list. The untyped list is most normally an array list, but they're kind of going away from it, so you won't use it nearly as much as a regular list, a typed collection, which is a normal list. So what they're showing here is you have an array list. It's called numbers, a new array list with the method on it there. They do a numbers.add, so what they're doing is the array list numbers, they're adding a number to it, 3. Numbers add 7, and then they're putting numbers add test in here. The reason you can put a string called test in here is because it's an untyped collection. Being an untyped collection, it doesn't look to see if you're putting ints, decimals, strings, whatever in there. It's just saying I'll take anything. But then you do end up coming up to a problem, because as you're looping through to print it out or whatnot, so they have an int sum here. Do a for loop like we did yesterday and been doing for loops. Well, now they're saying int number, get the integer numbers and return them, and you have to cast it. That's what that int in the parentheses there is doing, is casting it. Am I still streaming on Discord? Yeah. So when they're doing this int cast here, because we have a string in there, that string is not technically an int, and it'll cause a runtime error. It'll compile, but when you try and run your code, it's going to break with a runtime error. And that's because you declare ints in here when you cast it, but yet you have a string in there, and that string makes it break. And that's kind of like we've been talking all along, that you need an integer to talk to an integer, a decimal to talk to a decimal, kind of a thing, a string to talk to a string. Well, because you're declaring this number here an integer, you cast this numbers as an integer. It's expecting integers, but you have a string in there, and because of that, it ends up breaking. So that's why they're trying to go away from these untyped collections, is because it can cause a lot of problems when you put multiple types of data types inside of them. So now what they're doing is just using this typed collection, and at the top of our Visual Studio we see this system collection generic. This system collection generic, that's what we're going to be using in order to use these lists without having issues. You can see up here they're saying use that using system collection generic. I think most of the time it gets pre-populated for you. If it doesn't, you'll have to go type it in, but I think it does pre-populate it for us when we use that .NET framework. So what they do here now is they declare it's going to be a list, and inside the angle brackets, you have to have these angle brackets behind a list for it to work. You put your data type inside there. So they're calling it an integer here. Yeah.
Well, what do the angle brackets do? I know they're required, but like, what do they do?
Hold the data type inside of it. That's just the way it's set up for the data type. Without it, if you put parentheses or whatever, it won't work. It has to be the angle brackets for that, for the list. So then we declare our data type. We give it our list a name called numbers. We'll do a new list, put our data type in there again, and then the parenthesis behind it to use any methods or anything like that with it. So here they're kind of doing like they did before. They're doing a numbers.add, putting a 3 in there, numbers.add, putting a value of 7 in there. Now if you try and do that numbers add and put a string in there like the untyped collection, it won't even compile. It breaks. It prevents it from even having a runtime error because it won't compile. So when you push your little green button up here to start running, it breaks right away. See, like at the bottom it says build started, build 1 succeeded. Your build won't succeed, your build will fail, and it'll tell you why, that you're trying to put a string in an integer type of a list. So that's why they're moving more towards these type collections, just so it gets caught right away and you don't have to worry about it breaking during a runtime error. You want to try to avoid a runtime error at all possible, because what that means is you're starting to run your code, they're doing stuff in your program, and somehow you coded something wrong and it breaks right in the middle of your application. Then you either have to shut it down and start over and hope you put the right data in the next time or whatever, but you want to try and avoid those runtime errors at all, if at all possible. And as we start getting into some of the try-catch blocks later on, that's what those try-catch blocks do, is try and prevent some of these runtime errors by throwing a notice that there's some issues going on and that there's ways to get around it. So here they do their for loop again. They're declaring a variable with the data type of int, assigning it that numbers list that they created up here at the top. And because our number variable that we created is a data type of int and our list is a data type of int, we don't need to do any casting with it. We don't have to declare the new array or the new list being an integer or anything like that. It already knows, so there's no cast needed. We won't have runtime errors. It should work at that point. So that's called a typed collection. That's what we're going to be using probably from here on out through the rest of our labs if you decide to use a list instead of an array. A list of string elements is just the same way. Declare a list. Data type is a string. They're calling it titles. New list, string. List of decimal elements, same thing. A list, data type is decimal. They call it prices, then the new list, and they put the decimal data type in on the right hand side also to make sure it's the same. And here they're setting up a list of strings with a capacity of 3, just like we did with the arrays, where we put the capacity in the square brackets. This time we put it in the parenthesis to hold how many are in there. You leave it blank up here, and then you can put as many items in your list as you want. You don't necessarily have to declare it with a list, because a list is dynamic and will keep growing as needed. An array does not. An array, whatever you tell it that size, that's the size it has to be. If you make it bigger than the size you declare, we saw yesterday, you get that out of bounds exception that gets thrown. So common properties and methods with the list class. You got index. Index works the same way as an array does. A list starts, first element is 0, just like an array. So if you want to access the first element in a list, you just give it the index of 0, and then you get the first element coming out of that array. Capacity, you can get or set the number of elements a list can hold. Count gets the number of elements in a list. The method add allows you to add more elements to your array, or your list, I should say. Clear removes all the elements from the list and sets the count property back to 0. Contains, you can check to see if the list contains a specific object. And as you're doing some of these labs, I believe the last one where you have, was it movie titles or something like that? What's that? No, okay, the one before that. It has like 3 parallel arrays you use. You do a search to see if the movie is there or not. That one does a contains, because you have to search to see if it contains part of the word that you're looking for, and I'll kind of show you an example of that here in a bit. Insert, you can insert an object into a certain spot in the index. So if you have 4 items in your list and you do an index 1, it will put the object that you enter in there in the second spot in your list. Remove, you can remove an object from the list. Yeah, Paul.
Whenever you insert something in a certain index, just push everything.
Moves it over, yeah. You can do a binary search, searches for a list of specified object and returns the index for that object. We kind of looked at that yesterday with the array. It works pretty much the same way. You find the object in your list, it gives you the index number, and then you can use that index number to reference another list. And then the sort, which sorts it from ascending order. So an example here is they're doing a list. The data types are a string. They're given the list the name of last names equals a new list, strings, and they're setting it for 3 elements in this list. You can see they do a last name add. They add Bame, Martinez, and Merock. Well, then they added Taylor, and because we set it for 3, but we're putting a 4th one in, it automatically doubles that 3 to a 6. If we put 7 of them in, because we went over that 6 elements, it doubles that 6 elements to 12. If we put 13 names in that list, it'll double our list to 24, and so on, just so it doesn't get an out of bounds exception. This way, that's what makes the list dynamic, is that you can keep adding them and not have to worry about a size, not have to worry about going over a size. Even if you declare a size for it, the list up here in the top, even if you declare a size for it and go over it, it automatically will resize your list for you. So that's the nice thing about a list. And like when you work with databases, that's why you use a list most of the time, because you don't always know what you're going to get back from a database when you do a query on it. So this list can handle whatever comes back from the database, and then you can go do what you need to do with it, whether it be a search looking for certain names or values or whatever in a list. So that's why you'll see a list used a lot more working with database stuff. Syntax for retrieving a value from a list. Syntax for retrieving it is just like an array. You do the name of your list, just like we did the name of the array. You use the square brackets, and you put the index number in you want. So if I have a list, like here with these last names, if I wanted to get the last name of Bame, I'd put last name square bracket 0, and that would return the first element out of that list. Martinez would be the square bracket 1, Merock will be 2, and so on down the list. So just like we did an array, that's how you would index, get the index from it. And here they're showing you in this example, creating a list that holds decimal values. You can see we declare a list, give it a decimal data type, give it a name of sales total. And just like with the array, if you want to assign your values on the same line, or with the array, you just put the squiggly brackets around it and then put your data type in it, just like we did with the arrays yesterday. Squiggly brackets and then all your data in there separated by commas, just like the arrays. Lists and arrays are pretty close. The way you deal with them is almost the same. The biggest difference is the dynamic ability to grow and do a couple more things with them that you can't do with arrays. So this here is the code that retrieves the first value of the list, just like I was saying. They're calling it a decimal, giving the variable name sales1, assigning it the first index of our array sales totals. That 0 is that first index again because it always starts at 0. And you can see in our list up here, 3275.68 is the value that's going to end up getting returned because it is the first element in our list. Keep wanting to say array, but we're talking list today. So code that inserts and removes an element from a list. We have our sales total list here again. And then we're going to insert. We're inserting at the 0 element, which is the first one in our list, and we're putting 2745 in there. So then when it says bring back the element at 0, now we're going to have 2745 at element 0 instead of this 3275 because we inserted it like you were asking, Paul. We put that value at the 0 element or index and it shifts everything over to the right one. So then when we check for this first index, second value in our list, then we get that 3275 because it shifts it all over one when we put that one at the very first part of our list. You can remove it at 1, so then this one, sales totals dot remove at, they put a 1 in here. That removes the second element because 0 is the first, 1 is the second. And then sales 2, they're given the value of sales 1, which then, since we've removed the second element, which technically would be this one after we entered 2745, that 4398 now becomes our second element with an index of 1, and so that's why we get that 4398. And I'll show you some of this here in a second, actual code part of it. Code displays the message in the list box, or the list in the message box, I should say. Same thing we did yesterday. Declare a string to hold the value that's going to show up. Do a for each, walk through the list, set it the string to pick up all the items out of the list, and then they display it in this message box. So same thing we did yesterday in those demos. Code that checks for an element in the list and removes it if it exists. So we declare a decimal, give the variable name x. That's all right, you can let it go. Assign it the value 2475, and then they say if sales totals dot contains, if it contains an x, it would show it. Here they're saying remove, they're removing the x, so it would remove that 2475. Code that sorts and searches a list, the dot sort, and then they're doing that binary search sales 2, just like we did with the arrays yesterday. So it's common properties of the sorted list. You use a key, it gets or sets the values of the elements with the specified key. I think we may do this in one of our later labs for some reason. I feel like we do. But you have the keys, gets to the collection that contains the keys in the list. Values gets a collection that contains the values. The keys and the values usually have to match up. You usually have to have a key and a value together to get it to work. Capacity gets or sets or number of the elements the list can hold. And we've been talking about that since we started talking about arrays. Count, same thing, gets the number of elements in the list. And then with the sorted list though, when we do an add, instead of just putting a value in there, we have to put a key and a value in there. And as you'll see as we go through here, we'll see an example of how they add a key and a value. The key ends up being a string, the value is a number. Clear, same thing, it removes all the elements from the sorted list. Contains a key, you can do a search to see if it does hold that key. If it does, it comes back true. If not, it comes back false. Contains a value, you can check to see if the value's there. Same thing, it returns a true or a false. You can remove the key. You can remove at an index, just like we've been talking with these lists. This just happens to be a sorted list instead of a typed list. So the key for the sorted list item, the value associated with that key. And you'll hear key value pair a lot because the key and the value have to match up. How to create and load a sorted list with separate statements. So instead of just a list, now we call it a sorted list. And we have a key and a value. Our key is going to be a string. Our value is going to be a decimal. We give it the name of sales list. We say new sorted list, again a string and a decimal, and we set the capacity or the list size at 4. So here they're adding the values kind of like we did in the regular list up here. So this is just last name add the item you want in the list with these key value pairs. Now we got a key which is Finkel P and the value is at 4398. Adams A is the key, the value is 3275. And again, the key, value. That's how these sorted lists work. So collection initializer. So this is just kind of doing it all on, I would say one line, but technically it's not one line. So they're doing, again, a sorted list, a string and a decimal data type, calling it sales list. And instead of doing that sales list add, they do a squiggly bracket to hold everything in. And then inside that squiggly bracket, they add another squiggly bracket and put the key and value inside of those, separated by commas. So that way you can just initialize it right away instead of having to do all these extra lines of sorted list dot add. An index initializer inside a collection initializer. So they're doing a sorted list, giving it the string and a decimal as the value types for the key and the value. And then Finkel P with the index initializer, and then the 4398, the collection initializer. It's set up like that. You don't see this as much in the real world. Code that looks up a value in the sorted list. So they have a string called employee key. Name is Lewis J. A decimal data type for sales total. And a sorted list called sales list. They're looking for the employee key and seeing if it's in there, and if it is, it turns true or false. Here that converts a sorted list to a tab delimited string, and that's kind of what we saw earlier. Declare a string, leave it blank, and as we add these items into it, we make them into strings. We're using this employee key, employee value, and then print them out to a message box. I'm not going to go too much in this. We don't do a whole lot with it. We don't use the queue at all in this class. In the real world, you might. I didn't see it much in my career. But same thing, you do a count. NQ adds a specified object to the end of the queue. So you don't just put it in wherever. It gets put in at the end. Gets the object at the front of the queue and removes it from the queue as DQ. Clear removes all the items out of the queue. A peek retrieves the next item in the queue without deleting it. And you guys probably heard of a queue, like things getting racked up in a queue and stuff like that. That's kind of what they're talking about here. Code that uses a queue. So instead of a list or a sorted list, we use a queue. Give it a data type of string. Name it name queue. It's a new queue with the string value, and then you got your capacity you can set at the end here. You don't need to necessarily with, like I said, any kind of lists. So they do a name queue called end queue, so they're putting these values at the end of the queue. Bain, Martinez, and Muroc. String, and then they're doing the same thing we've been doing all along with getting these values. Here they're doing a while loop instead of a for loop or a for each loop, getting each value out and putting it into a message box. Properties and method of the stack class. You may see the stack a little bit more than the queue, and probably even an assorted list. But you got the property count, gets the number of items in the stack. Push, you put the object in it. It's just like the add that we were looking at the list. Adds the specified object to the top of the stack. Pop gets the object at the top of the stack and removes it from the stack. Clear removes all the items out of the stack. And peek retrieves the next item in the stack without deleting it. Probably hear push and pop a lot, especially with arrays. When you start working with some arrays, you can do push and pop, where it removes something from the end and puts it at the beginning. Code that uses a stack. So the type of list we're using is a stack here. Data type is string. They name it name stack. It's a new stack with the data type of string. Here they're pushing it, putting Bain and Martinez in, putting Muroc in, and then at the end they pop them to get them to come out, and you can see them there. Like I said, we don't use that. I know we don't use it in labs at all. In the real world, you might occasionally use it, but more often than not, you're just going to use a regular list. Syntax for retrieving the value from an array list. Do the data type, the array name, and the index, just like we've been doing. All this is exactly the same as we've been talking about since yesterday. Code that creates an array list that holds decimal values. So you have a decimal data type. The square bracket showing that it's an array. You got new sales total as the name of the array. They assign it the values. Now they have an array list. Sales totals, new array list. Go do a for each, walk through, get each decimal value out, and then adds it to the sales total array. Another way to create an array list, kind of the same way we've been looking at. So I'm not going to go too much in depth on this. It's been the same thing we've been doing. Sales total insert at index 0 puts the value in at the first one. Shows the value of the first index. Sales total 1, since it got added, it moves that over 1. Remove it at 1, so it's removing that second element in your array, but it's at the indexed 1. And then when you check again, that second value will be gone. The third value moves into the second spot. So just like we talked about, it does the exact same thing. Most of these lists and that are all the same. Array list, untyped list, a typed list, a sort list, a queue, and a stack, pretty much all the same. They all kind of work the same way. Code that checks for an element in an array list, doing the same thing, seeing if it contains it, sorts it. And then these are just, if you decide to do any of the things in the book that aren't in the labs, that's just examples of them here. I'm not going to go into those. Decide you want to do it, go for it. I would recommend it. Just the more practice you get, the better. So objectives of part 1, applied, given the specifications for an application that requires the use of a one-dimensional rectangle or jagged array, write the code that works with the array. Given the specifications for an application that requires the use of one of the collection classes, and the collection classes again are those lists presented in this chapter, write the code that works with the collection. Distinguish between a loop and a for each loop. Anybody know what the difference is again?
The for each goes through like a collection, and then for just iterates on a number.
Yeah, the loop will go through a certain amount of times. depending on how you set it up, the for each loop will go through each item in the array one at a time. Explain how the array class can be used with an array. Describe how the null conditional operator works and when you would use it. Distinguish between an untyped and a typed collection class. We just looked at those. Describe the difference between these collections classes, a list, sorted list, queue, stack, and array list, and we just did that. And like I said, this array list is getting outdated, so I wouldn't worry too much about that. I would just kind of focus on this list. Maybe a sorted list, and then a queue and a stack kind of work the same way as the list and the sorted list, except sorted list needs a key and a value to work together to work properly. Like I said, the list is what we'll use most often in this class, so I wouldn't get too caught up on that. So that's chapter 8 and in a nutshell. Today's lecture was a little bit quicker than yesterday's. Yesterday had a lot of stuff to do with the arrays. The lists kind of work with an array, or like an array, so if you have an idea how an array works, you should be all right with a list. To show you some demos on that, let me do a file new project. I am going to start out with a console app just to kind of show you some array stuff and list stuff real quick. So console app is what I want. Let's do array list demo. I'll put it in my examples folder, as you can see here. I'll leave my solution name the same. I'm not too worried about that. I'm going to go ahead and create it. What did I have on there? Yeah, I'll save it. Who cares? So first thing I'm going to do is we'll take a look at a list. Is it a list is a data structure that represents a list of objects that can be accessed by index similar to an array, but can dynamically increase or decrease in size, and you have to use system.collection.generic in order for it to work. And as you can see up here at the top, we already have system.collections.generic called for us, so we don't have to worry about it there. Doing that .NET framework puts a lot of that stuff in there for us already, so we don't have to worry about it. So I'll start out with an array. I'll do an array of strings, so I'll do string. Say it's an array, so our data type is string. The square brackets say we're doing an array. I'm going to name my array food. I figured I'd get most of your people's attention. And then we'll do a new string. I'm going to set the data size to 3. So now we have an array named food that can hold 3 values into it. So I'll assign my values and do food 0 since it's the first item in the index there. And we'll call it fries. Where'd trim come from? Fries. We'll do food 1. We'll call it pizza. do a food 2 equals hamburger. So now I got my 3 pieces of data inside my array. That's what it calls for, is 3 up here. Now I want to walk through these. I'm going to do a for each. And so what I'm doing my for each is I'm just saying these items are going to be a string. Each one of these inside of the food array I'm just going to call a string or an item. So then I can just do console.writeLine, and I'm going to print each item out. So each item in my food array will get printed out to the screen. So if I run this, you can see I got my fries, my pizza, and my hamburger now showing up in here. So what's going to happen if I try and add one more down here? So we'll do a food. Yeah, so now we should get an error, and I'll call it steak. So now that we're trying to put 4 pieces of data into our array that we said is only going to be 3, we run this. You can see here we get this unhandled exception, system.index_out-of-range exception. Index was outside the bounds of the array. That just means we're trying to put more data in this array than we said it can handle. If I change this to 4 now and run it, it works. We see our fries, our pizza, hamburger, and our steak that we added. So I'm going to go ahead and comment this out real quick, and then we'll take a look at a list. So now a list, we say list, there's our angle brackets. We'll do a string. A list, a new list. And it's a string, but we don't want to call it list. I'm going to call it food again so we can see how the array and the list work together. So now, as we saw in the PowerPoint slide just a second ago, when we add values to it, we have to do food.add, and we're telling it we're going to add fries, food.add pizza, and food.add hamburger. So we'll do a for each again. Item and food.
I have a question.
Yep.
If you're going to do an array, why don't you just make a list for it? Like, why is there a difference between like an array and a list?
Sometimes you want to have an array if you know the set size of it and what you want to put into it. You can just use an array. If you don't, you can use a list, and that's what I said. More often than not, most people would rather use a list just because it can be dynamic and you don't have to worry about setting up the array and all that kind of stuff. Don't have to tell it what data size and all that you want. That way you can just use a list. On these labs, if you want to use a list, go ahead. I don't care one way or another. Like I said, they pretty much work in the same way. The real world, you'll be using a list a lot more than you will array, especially if you're going to be working with databases and stuff like that. So console.writeLine, we'll do the item again. So now if I run this, we get our fries, our pizza, and a hamburger again. And some of the things we can do with it is we can do a remove. So we'll do a food.remove. And we're going to remove fries from our list. Fries. Run that again. And now you can see we only have pizza and hamburger listed because we moved our data of fries out of there by using that remove fries. Comment that out. Then we can do a food.insert. And we're going to put it element 1, or index 0 I should say, for element 1, and we'll call this one sushi. We got a lot of sushi fans in here.
Yes.
What's better, sushi or ramen? So we'll do a food.insert. We're going to insert into the index 0. And our element will be sushi, and it should show up at the first of our lists. Let's run this and hope that works. And you can see we have our fries back because we took that remove off. And sushi is in our first element because we are setting it at index 0. Let's set it in index 2 and see what happens. You can see it gets moved down to the third element because we set 0, 1, and 2, which makes it the third one in our list. So that's the insert there.
Okay. So my next question is, why would you do insert? You can just add to it.
Because what if I want to put it in the middle of the list instead of at the very front of it? Add just puts it in there, or at the end, it keeps adding it to the end or whatnot. This we can specify exactly where we want it to go.
No, wouldn't I just put it like, say like in between fries or pizza if I want it there?
So then you have to do a food.add in there. And put it in. We run it. And we do have our steak in there, but instead of doing it like that, we can just do that insert and tell it exactly where to go. We don't have to worry about going through the code and looking for it. We can just say right here, put it at number 2 and then be done with it instead of having to go through our list of ads and pick out where we need to stick it in at.
I'm guessing that's like thinking of like gigantic code.
If you have a big list or something like that, yeah. So saves a lot of time, a lot of effort having to dig through it. So then I can do a count. So I'll do a console.writeLine food.count. And this should count how many items are in our list. So let's run that. You can see up here it says 3. We do have 3 fries, pizza, and hamburger. It's telling us we have 3 up there. So that's how the count works. So you can tell exactly how many you have in your list. In case you need to compare something, check and see how the size of your list. Like I said, if it's a giant list and you want to know what's in it, you can do a count and see how many items are in it. Do another console.writeLine.
How do you make the count? Like, what if you have like multiple like lists or arrays in one program? How do you have the dot count like focus on one specific list or array?
By our list here is called food. So if you look, our list is called food,
Okay.
and so we're doing a food.count. If it was called sodas, we could do it sodas.count. It would count up the number of sodas in our list like that. So if we do a console.writeLine food.index of, and let's see what our index of hamburger ends up being. Gotta make sure I put my 2 brackets around it. I got an open bracket here, an open bracket here, so I need a close or a parenthesis, open parenthesis, open parenthesis, so I need a close parenthesis and close parenthesis to make sure it works. So we run this and hopefully we'll get a 0, 1, 2. And hamburger is at 2, so we get the number 2 up there for the index of. Index of 0, 1, 2. Hamburger is at 2, so it shows us the index of being 2. And then we'll do a last index of, so let's add another French fry in here. Yep, so that's what I'm going to show you here. So we're going to do a console.writeLine food.last index of, and then we're going to call fries. Again, we need 2 parentheses at the end. We have an open parenthesis for that right line, and we have an open parenthesis for last index of method. Then we have to close them both and our semicolon. So now what we should get is a 0, 1, 2, 3, because it's checking for the last index of the word fries. We got 2 of them in here. One's at 0 and one's at 3. So we should get a 3 back for that because we're checking for the last index of it. So let's run it. And again, we do get 3 up here because we're saying we have 2 fries, get the last index of fries. The last one happens to be in 3, so that's why we get it. Yeah, Paul?
So if you were to have, like how you have it now with 2 things of fries in there and you just did index of, would it return 0 and 3?
Well, let's try it. So since we're just doing index of, it just finds the very first one and gives us the index of that first one.
Okay, that makes sense.
So let's see if we run them both at the same time. Now we get 0 and 3, 0 being the first one, 3 being that last index of. So that's a list there, using a list. Some of the different methods you can use in a list makes it a little bit nicer than messing with an array. Like I said, it's dynamic. We could do size it up here and say 2, but yet we still have 4 things in here. If we run it, it still gives us everything. It doesn't throw an error being indexed out of range because it grows dynamically. We say 2, we have 4, so it's going to double it to 4, then 8 if need be, and keep growing as we keep adding items to it. So that's the nice thing about a list. An array we do 2, when we try and run that it breaks because it's out of index range. This one here, it just keeps growing dynamically, so we don't have to worry about it. A lot of times you don't see a list with a size in it. Most of the time it's just with the empty parentheses like that, and then it's just whatever size it is. So that's a list. And now I will do a couple examples of your labs that's going on. They're not going to be quite the same. They're going to be probably kind of ugly compared to your labs, but so we'll do a Windows format for this since that's what we're using in the labs. Before I start this, since some people are seeming to take a break, let's take about a 15-minute break. Then I'll come back and I'll code these 2 labs real quick, just to kind of give you an idea of what you're going to be doing for your lab. And that way everybody's kind of here, hopefully, to see it without having to go back through the video. A brief kind of a demo of the zip code one and one of, I think it's the movie titles, and I forgot what else. There's like 3 parallel arrays that go along with it. So I'll kind of do something with those. Give me one. Alright, so I'm going to name this, I'll just say lab 2 example, or lab, I guess it's lab 1 technically. So keep it in my examples folder since that's where I'm stuffing most of my stuff at. So let me bring up the rubric real quick so I can get an idea of what it looks like, so I can lay my thing out. So I will add move this back over so I can see my toolbox. My toolbox, I'm going to add a text box. Text box, a button. My button there. I need a label for above my text box. And then 2 labels to the right of my button. So I can drag and drop. Got one there. I can hit, you can see my label 2 is highlighted. I can hit Control C, then Control V, and I'll copy and paste and put another one there. So a little bit of time saver if you're putting a lot of stuff on there. Again, we got to go in and set our properties for all of our controls. So my text box, again, the naming conventions that we're supposed to use. What's the text box start with? TXT, that's right. Text. Let me see how I did my demo real quick, just so I know what I'm calling everything. That's my L one here. So I'll call it just calculate here. My buttons are BTN, and I'll call it calculate. Button calculate, give it the name of calculate. This might not be exactly the same as the rubric for the lab because I'm not technically doing all that. So my label, how did I set mine up? Miles. And again, like I said, this is going to be different because I'm not doing exactly what the rubric says, just so I don't do your homework for you. Yeah, I know you hate it, but I don't think I said on here. And my label I'm displaying my values in at the end. I don't want any text there, so then as we go to code it, you gotta double click on your button to get your button click event wired up.
What did you name label 3?
My label 3.
And what did you do with text box?
Label 3, I just called label display result because that's where I'm going to display my result.
What's the text box?
The text box, I just called it text calculate. And again, using the naming convention, since it's a text box, I call it TXT. And then under the appearance, that's where I give it the name of I give it the name of no text because it's a text box. You don't have to put text in there. Some people put text in there just as a kind of a hint, kind of a thing. But So we'll double click on our button to get it wired up, ready to code. So I'm going to create a couple arrays. These are parallel arrays. I'm going to give them the value of an int. Call the first one miles, and like I said, this isn't going to be the same as what you're doing for the lab, so with them being named different, don't be surprised here. I'm just trying to give you some kind of example of how it should look and be set up. New int. I'm going to put 5 values in here. I think you guys have more than that for the 20, 40, 60, 80, 100. So I created an array called miles. I gave it the data type of an int. And again, you can see it's an array because of the square brackets. New int. I'm saying I want 5 values in my array. My values are 20, 40, 60, 80, 100. On your lab, that should all be zip codes in there. Doing a second array called charges. I think on your lab it'll be something close to that. And my charge is going to be 10, 20, 30, 40, 50. And again, this isn't going to be exactly like your lab, but it's going to kind of give you an idea of what you want to do. So now to go through my arrays, I'm going to do a for loop. Int I equals 0. I is less than miles, because that's what I want to run it against. And then I want to increment my counter as I go through it. So then I'm going to say if, in my if statement here, I'm going to get the data out of that text box because that data comes in as a text, but my miles are an integer. I got to do something to get them to be able to communicate with each other. And what do you have to do there for it? If I'm creating, if I have a string and I need it to work with an int, what do I have to do? I got to convert it. Convert to int. Take 32, it's the most common. And my text is txt. Calculate text. And I want to compare that against the miles in my array. So, and again, when we compare something, especially in the if statements, we don't use just one equal sign, we have to use 2. That's how we do a comparison. If we just use one equal sign, that means we're assigning it a value, and that's not what we want to do here. We want to check to see if what the user puts in is the same as the miles in our array. So then I'll do label display result dot text, since it's text that we're putting out, equals, and I'm going to use string interpolation just because it's easier. I don't have to convert anything, makes it a lot nicer. I'm going to display my charges that go along with whatever miles are being entered. I want the miles I to go with my counter and my loop, and I want the charges I to go with that also, so that's why it's like that. I'm putting a :C at the end of mine just so my charges show up as a dollar symbol, since I didn't actually set it as a string or anything up in my array. I think in my next example I'll kind of show you how you could do that if you want to. It's just up to you. So I got my if statement there. I'm going to put a return in here, just and my else statement, my label result I'm gonna have that text is gonna say, and I can leave this a string since it's gonna be a string, so I'm just gonna say not a valid distance. I think yours might say not a valid zip code or something like that maybe. So you can see I got a red squiggly. I'm missing one of my, if you look, you can see the dotted line going down matches my squiggly brackets up. I'm missing a squiggly. Put that in, it should clean everything up for me. Now if I want to run this, like I said, this isn't really a good real world example because I'm not covering all the miles and that. I'm just putting some in as an example so I know what I'm putting in. So if I put mile 1 in, 1's not technically my array, so I should get my alert saying not a valid distance. There's my not a valid distance. If I put 20 in there, I get a $10 charge, and you can see in my display result down here I have the :C. That shows it as currency, even though my array shows it as a 10.
It's saying still it's not a valid result. Even when it's been 20.
That return says when I put the number in that I put in that's in this array, find it, and then stop there, jump out of our loop. Don't keep looping through if we forget this array, and then try and run it. It's going to keep looping all the way through the 5 times or whatever it is. And because it does, that 20 it doesn't find, it won't find any of them. It loops all the way to the end of our array, which is that 100. That it will find and display if we don't have that return in there. That return just tells it to return back to the code. Don't keep looping through. So that's kind of how you're going to set up the zip code one. You'll have your zip code and your charge, and you'll just kind of walk through it the exact same way to get the values out of there. And now I will do another one real quick. I think what is it, the movie? The movie one here with the 3 arrays on it, just to give you an idea how that's going to work. The night stayed one, you have 4 values over here. You can either make it 8 for 1 and 2, 3, 4, 5, 7, 8 or more, or you can just use the top part of the range and say if it's within this kind of a thing. 1 or 2 nights, you know it's 200, 3 or 4, 180. So you can either have it at 4 and do the one of the values in your range here matched up on the number, or you can code it out for all 8 different things. So you do 1 night, 2 night, 200, 3 night, 4 night, 180, 180, 5 night, 7 night, 160, 160.
Hey, Mr. G.
Yep.
I just basically hard coded all the odd numbers just so I can keep the 4 values at the top. Is that fine? Or
You shouldn't need to hard code anything
like
in
the
it.
If else added it, kept doing else, but unless there's another one.
The if statement should just check to see how many nights you're putting in. And like I said, you can do a range like 2, 4, 7, 8. And then your rate be 200, 180, 160, 145. Do your loop through the night.length or the nights.length, whatever you want to call it. And then check, do an if to see if your night stayed equals or is less than or equal to the nights in your array. So then if they put a 2 in, it's seeing if the 2 is less than or equal what you enter. So if you enter a 2, it can check to see if it's a 1. So if it's 1, it'll see if it's less than or equal to 1. and then you'll know that it's going to be that $200 price kind of a thing. And then else, just give the rate whatever it is. So let me get set up here for this next example. It's going to be another Windows Form application. I'll just call it, what was it, a movie that we're doing here? It's a game database. I'm just going to call mine movie example.
The one under the games one is the movie one too.
Is that what it
Yeah,
was?
there's like two of these same.
Oh, okay. I knew one of them had 3 arrays in it, and one had 2. So the game one has 3. I guess technically the movie will have 3 of them too, since you need a name, a director, and a description. But this will kind of get you going on both of them technically. And then of course the credit card masker, Mr. OG, has a video out on YouTube. We watched it the other day. Go search that up. Watch his video on that, on how to loop through a string and check each character. And then there's like 2 of them that kind of coincide with this. We watched them both in class. I'd go back out and double check those. If you go to his, I think his videos or whatever it is, and scroll down until you get to like almost a year ago, it might be like 10 or 11 months ago. That's where he does an example on how to properly do this credit card masker. That's why I'm not going to do one in class, because he has a good video out there on how to do that. So what do we need as far as our window layout on this? Text box and a search button. Text box and a search button. Button. Then I guess he's got like 6 labels down there. So Control C. 2, 3, 4, 5, 6. I try and put them in order. That way my tab order is already set and I don't have to deal with it later on. Not that you have to do much with these labels, but just as I say that, I put 5 ahead of 4. 5, 4, 6. What do I have mine called? I'll go ahead and do my labels real quick. And the label naming convention is LBL. Movie title, text. If I know I'm not going to change the wording on my label, I usually put text at the end. That way I know nothing's going to change on it. A lot of times for my label, when I know I'm going to put a value there, I leave that text off of it. So like if I have result as a label, I put it result text. If my result is going to change based on my answer, I leave that text part off and just put label result, so I know what's going to move and what's not going to, or what's going to change and what won't change. So I'll call this movie title. I call this media type. And like I said, mine aren't going to be exactly the same as this lab, but it's just going to kind of show you how to set it up and do your loops and stuff for some of this. Label 3. Price, what's my labels? Don't want any text on the labels I'm going to put stuff out to. Media type. So there's my labels are done.
What did you have for movie and price, the ones that are invisible?
You can call them whatever you want, honestly. My invisible ones, my price.
What did you do for movie?
For movie, I think I just called it movie. Yeah, label movie. This is label media type. And this is just, I think, label price. Yeah, label price. So my text box, I'll give it the value of txt as our naming convention, and I'll do search box, and then my button, I'll just go btn search, and up here I'll name it just search. So there's a quick layout. Like I said, it's not going to be exact on this lab, but I'm just kind of giving you an idea on what you need to do for your lab. And again, our button here is going to be our event. So when I click on our button, we'll double click it, get it wired up. You can see it's our button name is button search, btn search underscore click. That's the click event that we want to run each time for our code. So this time I'm going to set up 3 arrays. They're all going to be strings. I'll put 5 values in them again. You can call your movies whatever you want. Put my favorite first.
Did you actually watch that?
No, I have not seen it. No.
Yeah, he has. That's the second time he's mentioned it. I have.
Actually, one of my more favorite movies has been the newest Batman that was just released. I've probably seen that thing 100 times already.
Oh yeah, that one's bad.
Yeah. Started watching Mario Brothers one night. I couldn't get through that. X-Men. Just watched Deadpool, the first one, the other night. And of course, everybody loves Star Wars, don't they?
Not everyone.
What?
I had a friend in high school who was born on May 4th.
Oh, yeah.
She hated Star Wars.
Well, I mean, back in that case, you have to hate it
So then my next array is going to be, I'm going to call it media types. And again, it's going to be different than what you're setting up for your labs, but I'm just going to go DVD, Blu-ray. I'm going old school here with the VHS tape, laser disc. Anybody ever have laser discs? Or is that before most of your times? And the ever popular Betamax. Yeah, I'm old. What can I say? Yep. Thank you. Yeah, I don't need any comments from the peanut gallery over there.
What is Betamax? I have never heard of Betamax in my whole life.
I figure you're probably too young to hear of that. That was supposed to be,
I've heard of it.
it came out just before the VHS, and it was supposed to be better than the VHS, and the VHS killed the Betamax tape. So
When was this, like, how many?
early 80s, mid 80s, 1980s.
Yeah, I'm from 2000.
And so you probably weren't even born yet then, were you?
I was from 2000, from 2005.
And then finally I need my last array. It's going to be another string. I'm going to call it prices. And again, we got to have it 5 since it's a parallel array and they all need to match up. So I will put $18.99 in there for the price of that. It'd probably be more expensive if I had Barbie on a Blu-ray instead of just a DVD, but $24.99. $49.99 for this good old VHS tape here. $43.99 for our laser disc. And we'll go on the cheap with our extremely dead Betamax. I'm going to put a $sign in front of these. That way I don't have to do any conversions or anything. When I print my string out, it'll have a $sign in front of them. Just got to show you how that can work by using strings. Got to put my semicolon at the end. So now I got my 3 parallel arrays. One's called titles, one's called media types, and the final one's called prices. So now that we got our arrays initialized and the values set on them, we're going to do a for loop. That way we can walk through our arrays. And i's, we want our I to be less than our title length, which is just 5. So we know how many times we can expect it to loop through. And inside this for statement, we're going to do an if statement. And again, with an if statement, we're checking a condition to see if it's true or false. So I want to take titles I. I'm going to do it .toLower. And what this toLower does, it takes anything typed in our boxes and makes them lowercase. So that way, if they type in Barbie with a lowercase b, it'll still pick it up. If they type in Barbie with an uppercase b, it will make it to a lowercase b and still find it. And then we're going to use that contains. I think one of those labs say to check on how the contains works. And we did talk about it with the lists. I don't know if we spent much time talking about it yesterday in the arrays, but oops, so my, what did I call my text box again? Text search box. So, and this contains, I want to look for, oops, nope, I forgot something here. And enter. So I need to do a string for my search box here. So string. Text search box text. And so what this is doing here is whatever they're putting in the search box, our text search box is just getting stored in a variable called search box. So I'm going to use that search box to lower. Or I'm going to have to check media types. Media types I toLower. And then do another contains. And do our search box again. toLower. So what we're doing on this line of code is we're saying if our array of titles, as we walk through here, whatever number it happens to be, make it go lowercase and see if it contains any of the words in our search box that we enter. Put those at lowercase so they match up. Or look at our media types, make them all lowercase, see if they contain any of the words from our search box. Anything in our search box we move to lowercase. And I don't want that semicolon there because this is an if statement, and that's why it was giving me that green squiggly saying something might not be right here. So now if it finds any of that stuff, whether it be the title that we're searching for or a media type that we're searching for, we're going to put it out to our labels. And I will start with my movie first. Call it titles I. And so that's saying if we find that title in there, put it in that movie text label that we have, or movie label with the text. I'll do the media type next. And this is kind of where IntelliSense is nice for you, and like I keep saying and said it over and over, this is what the student kept letting it do for him. So he would just, it would get ready to tell him what to do, he would just tab through it, but yet he wouldn't know why it said media types I and what it was trying to do. And all that is we walk through this loop and we check these strings in our array, and if it happens to match it, that I gets set to whatever this loop is, so they all match up together in our arrays. And then price is our last one. Price, and then again, you can use a return or a break here. They both should work. I'm using a break in this one. And I'll do an else statement here and put my labels in again. I don't want titles though. I'm going to have it say movie not found. And then my label media type, say the same thing. And then finally my price. I need to have that say text. Label price dot text. So that should be all we need for this one. So looking at it, we created 3 arrays with the data types of strings, set them at a length of 5 or a size of 5, gave it some values of movies, media types, and prices. We declare a string data type for a variable called search box. That search box just takes whatever is entered in our text box here, stores it in search box. Do a for loop to walk through our arrays. Do titles.length. That dot length says our length on our array is 5, so I is going to see if it's less than 5 as it walks through our arrays. And you do the same thing for a list. If we use the list, you just use the list name dot length, and it would walk through your list the same number of times as the length of your list. And we're doing an if statement inside here and saying if our titles, and the title, it starts out at 0, which would be Barbie, 1 is Superman, 2 is Mario Brothers. Switch that to lowercase, so like Barbie, the B in Barbie, the S in Superman, M and B in Mario Brothers all get lowercased. If it contains any of the words that are in our search box variable that comes from our text box up here on our window. If it contains any of that, switch it all to lowercase so they match. Or if our media type, and the I again is the variable that we use to loop through our for loop. Take that media type, so all of our DVD here, it's all capitalized, that would lowercase it all. It contains anything in the search box and it matches that. Give us our movie title, give us our media type, give us our price. This break says once you find what we're looking for, break out of this code, don't keep doing the loop. Else if it can't find any of that, display movie not found on our labels. So now if we run this, I guess I need to switch my drop down up here to get the right one. So now I'll type in Barbie and I can type it in lowercase and it should find it. And it prints it out as Barbie because that's what it shows up in our array. Barbie, the media type is a DVD and that price is $18.99. I can do Superman. And as Superman, it shows it's a Blu-ray and the price is $24.99. If I go back and type Barbie with a capital B, and actually I can type it all uppercase, this 2 lowercase here is going to drop it all lowercase, so it should find it anyhow. And there it is, Barbie again, even though we type it all uppercase. So that 2 lowercase, when you switch the text box and the stuff inside the contains, it makes it all lowercase. So it doesn't matter if they're typing capital, it doesn't matter if they're doing lowercase. This will always find it. So this is a way to handle capitalization in searches, is by putting that 2 lower on each side of it. So the 2 lower for the titles, the 2 lower for the contains out of our search box. That way, no matter what they type, it'll find it. If we don't have that 2 lower, then it's case sensitive. So if we get rid of the 2 lowers, get rid of the 2 lowers in here. Get rid of the 2 lowers here. Now it's case sensitive, so if we don't type Barbie in exactly like it shows in our array, it's not going to be happy. So let me run that and show you. So our Barbie has a capital B. If I type it all in lowercase, it doesn't find our movie now. So that makes it case sensitive. So if I type Barbie in like it shows in our array, it should find it, and it does. Barbie DVD. Again, if I do Mario Brothers lowercase, it's not going to find it because it's looking for a capital M in Mario and a capital B in Brothers because of the way our array is set up. Now it should find it, and it does find it. So that's what that 2 lower is doing, is making it so our search box is not case sensitive. It makes it nice. So then you don't have to worry about what the user types in. It's going to find it pretty much no matter what. And now the contains part of it, if we run it with this contains, I can just type in Mario, and it should find Mario because it contains the word Mario in here. So if I do a search now, it still finds Mario because that contains keyword here. The contains method says it does contain Mario. Mario's in our array. Go ahead and print it out. So if I type in an X, it should find X-Men, and it does find X-Men. If I type blue for my media type, we're doing a search on our media type too, so that should find whatever movie I have as a Blu-ray, so it should return Superman. There's Superman comes back. So that way it makes your search box a little more robust to be able to find any type of word, uppercase, lowercase, and that contains. as long as it contains part of it. So if I type in disk, it should find that laser disc, which is X-Men. If I type in beta, it'll find the Betamax. If I type in DVD, all lowercase, even though it's uppercase in our array, it'll find our DVD. And it prints it out just how it is in our array. It's uppercase for our media type in our array, so it shows it uppercase as our result. What else do I have down there? Star Wars. If I type in, I think ST should still bring back Star Wars. Yep, still brings back Star Wars because the S and T is in Star Wars. If you have another one that has ST starting, you probably have issues and may have to type in a little bit more to get it to work. If I type in star all capital, it should still find Star Wars. It does. Mario all capital, it'll find it. Type in Barbie all lowercase, it'll find it. If I just type in brothers all capital, it'll find it. So if I type in junk, it won't find it. If I type in Barbies, it won't find it. If I type in Barb, it should find it. There you go. So when you do these search boxes, make sure you put that to lower and the contains on it. That to lower will make everything so it's not case sensitive. You don't have to worry about what the user types in, whether it's upper or lower case. And that contains will pick up any piece of whatever they're typing in. I can't type in price because I'm not doing a check on price. I could put another or in here and do for price if I wanted to, but I didn't mess with that. I don't know if you have to do that in your lab. You might have to, but that kind of gives you an idea how to set it up. Makes it so it's not case sensitive and you can pick up partial words in your text or in your search boxes. So that's the 2 demos I'll do. Should give you an idea how to get most of your labs done. You said that credit card masker, go watch Mr. OG's video out there.